Hey, what's up, everyone? Before you get to the show, I just wanted to quickly record this video to let you know that my technology skills were on full display during this current episode. Excuse me. And I forgot to change my settings in Zoom, so you will not be seeing me during this interview. You will only be seeing Dr. Gordon. So just wanted to let you know. So apologies for the little technology mishap, but you always learn something new. But it was such a fantastic interview that I still wanted to publish it, the video version as well. And I also thought this will be better than just seeing a static image. I hate the static images. But anyway, just wanted to let you know on that. So thank you again for watching, and stay awesome, be limitless, and never stop upgrading. Peace.
Welcome to another episode of Optimal Health for Busy Entrepreneurs. I'm your host, Julian Hayes II, back at it again with another fascinating individual on a subject that I doubt you've heard about because most doctors have heard about. And I've hung out in a lot of clinics and hospitals over the last few years, with my father and everything that I talked about previously. And I've never heard the word glycans. So you're in for a treat here. And the reason why you're in for a treat is oftentimes now you're very familiar with biological age testing and DNA methylation, but you probably aren't familiar with the glycans, which is another powerful tool that may be even more powerful as a biological longevity clock. So I'm speaking with the world's leading glycan researcher, Dr. Gordan Lauc. He's the professor of biochemistry and molecular biology at the University of Zagreb. I hope I said that correct. He's also the author of 100 research papers published in the international journals and 6 international patents. He's also the official advisor to the Croatian government on pandemic management strategy. And even more, he's also the chief scientific officer at GlycanAge, which is the world's first direct-to-consumer glycan-based product that tests the age of your immune system. So without further ado, Gordan, how's it going, man?
Thank you for the invitation. It's a little bit late here already, but it's good. Let's have a chat.
All right. Thank you for joining me for that. A lot of times some of the hardest parts about this is the actual time difference, right?
Yep. It can be a problem.
Yeah. So I definitely appreciate that. And so the first thing I always like to do is go back in time. So if someone knew you from a child, could they predict that you're doing what you're doing right now?
Well, from high school, I think they would. Because I was already a nerd in high school, I was doing a lot of science. When I was very young, I wouldn't say so. Yeah.
So where did that bug kick in for science? What was that inspiration come from?
Well, my father was a university professor, so research was something that I was kind of growing into, and I love the idea of freedom, being able to do what you want, to research what you want. And I always wanted to be a scientist. So to be able to be my own boss and decide where I want to go and to kind of, if, I don't know whether you have children, but if you have or some kids, one of the most fascinating things about kids is how much they enjoy when they learn something new. Something like, I did it, I achieved it. It's fascinating. And as we are getting older, we are losing this joy of life, of discovering and learning. And as a scientist, we still have this privilege. So I can still be really excited about some science we are doing and say, wow, we found it, we discovered it. It's a great pleasure.
Yeah, I think about that, and I think about one of the things that I always try to remind myself is curiosity.
Yep.
It's curiosity.
And you know what? Curiosity actually gives the great joy if you discover the what you are curious about. You ask a question and then you don't have an answer, and then you do some research. And then it's this eureka moment. Wow, I got it. I understand. And in biology, there is a huge universe which we don't understand. We are usually fascinated with the stars and space travel, But there is a universe within us, which is even more complicated. Okay, maybe not as the entire universe, but it's extremely complicated. And we know so little about it. Because, in 50 years, I think people will be laughing at our medicine the same way we are laughing at the medicine from 150 years ago. So we may think that we know something, but we still know very little.
Mm-hmm. That's the exciting thing about life in general, is that there's always something new to explore. At least for me, that's exciting to me, is that there's a lot of things I don't know. Yep. And so getting into that curiosity, how did you land into glycans?
Oh, this was 30 years ago, so I don't remember all the details. I remember that it was one Friday evening and I was doing my PhD in Germany, and my boss came with a very cool new test to look into glycans, and we did some initial studies, and it became more and more interesting. And it's the field of glycobiology is kind of a small fraction of the global science, but it's growing. And it got a lot of attention now with this COVID pandemics, when everybody started to talk about the S-glycoprotein. Okay, there are glycans in the S-glycoprotein. So what do glycans do, and why are glycans important? And I think now more people know that there are glycans. Still, the majority of people don't understand glycans. Well, majority of people also do not understand the protein structure and such details. But even the majority of scientists who study proteins do not look into glycans, because glycans are complicated. And we all like simple solutions. So, and this was always a challenge for me. So as I said, I've been working in the field for 30 years. And maybe for the last decade or so, we really have tools to look into glycans. And for example, we already studied over 150,000 people. So we learned a lot about glycans.
So let's start at the basics then. What exactly are glycans?
So we know that there are proteins. Proteins are like a small molecular robots which do all the work in our body, most of the work. The majority of proteins, and nearly all proteins which evolved after we became multicellular. So after we stopped being a single cell organism, we became a multicellular organism. They're not only protein, they're not only polypeptide part, they also have glycans, which are modifications which modulate their function. Because there's one of the key kind of mysteries in biology, and this is that the simplest bacteria has around 5,000 genes. So E. coli has 5,000 genes. Humans have approximately 20,000 genes. It's only 4 times more genes than the simplest bacteria. And we are thousands or even millions times more complicated than the bacteria. And I think that the key tool which enabled us to become so complicated are the glycans. Because contrary to proteins, which are encoded by a single gene, so you have a gene, and then you have a protein, and then you transfer this gene to your kids, and they have the same protein. Glycans are encoded in a dynamic network of dozens of hundreds of genes. So it's a whole network which kind of fluctuates and makes a decision about protein glycosylation. So partly it's heritable because you got all these genes from your parents, but partly it's also environmental. There is epigenetics in the game, there is direct environment. So glycans integrate genetic information. This is what we inherited from our parents, they inherited from their parents. Epigenetic information. This is kind of molecular memory from our prenatal life until today. And direct environment, meaning what I ate yesterday. And all this integrates together into the glycome, which then affects all functions. For example, there are molecules called immunoglobulins, antibodies. They're the main weapon we have against all pathogens. But they also do many other things in our immune system. And the function of these antibodies is defined by glycans. So adding glycans to antibodies are deciding whether the antibody will activate the immune response, cause inflammation, kill the target, or if you put other type of glycans, it will suppress inflammation. Because we are always exposed to foreign molecules. They can be viruses, they can be bacteria. So if we are attacked by a virus, we want to kill that virus. So we arm antibodies with the glycans, which will activate the immune response. But if the antigen is food, we do not want to respond to that food. We do not want to respond to the dust we inhale. Then we have to have a way to suppress inflammation when we inhale something. And one of the ways how we do it is by putting different glycans on antibodies.
Oh, okay. So, and I imagine though that that this anti-inflammatory, pro-inflammatory, this can be influenced by our lifestyle to a certain extent, right?
This is heavily affected by our lifestyle. For example, we studied people in 27 different parts of the world. And we know that these pro and anti-inflammatory glycans, they change with age. So when we are young, they are more suppressing inflammation. As we are getting older, they are more promoting inflammation. But for example, if you live in a low-income country where your expected lifespan would be maybe 40, 45 years, then it will go much faster than if you live in a developed world where your lifespan would be 80 or 80 plus years. So the pace of changes from anti to pro-inflammatory is affected by your environment, by your lifestyle, and also within the location. So if you live in the same place, there are some people who will move faster and some who will move slower. For example, we were tracking 2,000 twins in London, actually in UK, for 15 years. And we had 3 samples in these 15 years. And some of the twins were gaining weight in that period, and some were losing weight, some were staying on the same weight. So the twins who were gaining weight, they were aging faster on this glycan scale of aging than twins who were not gaining weight or even losing weight. So just by getting obese, you become more pro-inflammatory, you age faster. And then you decide to lose this extra weight, and then your glycans can actually go in the reverse direction. So you can see your GlycanAge going down.
Now, is glycans and genetics, are they related some?
So there is genetic component in glycans. So approximately between 30 to 50% of our glycan composition is defined by genetics. So these are the genes which we inherited, and this is something we cannot really change. We cannot change our genes. And then for the GlycanAge part, it's around 50 to 70%, which is not genetic, meaning we can change it by making lifestyle decisions about how we live and what we eat and so on.
That's still a substantial amount right there. That's in our control right there. And that got me thinking almost like that this pro-inflammatory response in our glycans naturally goes up as we get older. It's almost like our cells are programming us that we've on a deep level that we've done our use on this earth. And now it's programming us.
Yeah, this is something which we don't know. So there is one hypothesis saying that there is a program which is making immunoglobulins more pro-inflammatory. This is putting more stress on an organism and actually helping to eliminate frail individuals. That's one hypothesis, because all individuals are using resources. If you eliminate old and frail, then there are more resources for the young, and maybe the population will be better fit. The other hypothesis is that this is a kind of accumulation of damage, because first, we have to be aware that until 150 years ago, only a small percentage of people would live above the age of 35 or 40. So there is no genetic pressure to keep us alive beyond the reproductive age, because the only thing which will leave after which will stay on the planet after we die is our kids. So we made our kids until we are 40 or something. Okay, some can make kids when they're 70, but most of the people have their kids before they're 40, now maybe later. And the rest is kind of a bonus period. There was no biological pressure to evolve protective mechanisms. And as we are getting into this age, so 40s, 50s, what happens is that this accumulation of small molecular damages is starting to cause more and more trouble. Because what is inflammation? So inflammation is a response of an organism to invasion. So when we see foreign objects, normally this is bacteria who enter through some kind of a cut on our skin or mosquito bite or whatever. So we see a foreign invader. And the first response is to kill it. So we send our immune system, all the cells of the immune system, they fire everything they can, and they kill this area where there is invader. So immune system kind of immediately reacts with a nuclear bomb. There's something and they drop the nuclear bomb, and then we see this kind of reddish swelling or whatever. And this is a good inflammation because it's killing the invader. But as we are getting older, inflammation can be induced by microscopic molecular damages, which are actually not a threat. It's just a kind of a wear and tear in the body. But this activates inflammation. And then you have these small inflammatory events all around the body, which is using huge amount of energy and which is also causing this destruction, and then you have repair, and each time when you repair something, there's kind of a micro scar staying, and there's this accumulation of more and more scars, more and more inflammation, less energy, and this is called inflammaging. So aging caused by inflammation, so this accumulation of molecular damage. And this is something, this is one of the theories where glycans change with age, and that this is kind of overactivation of the immune system, and it gets more and more activated, and then it becomes more and more pro-inflammatory. We don't know which one is correct.
And so I'm curious now, because I've been hearing more about glycans, and maybe it's just a bubble I exist in, but it seems that it's been becoming more and more popular. So why do you think that the glycoscience now is becoming more heavily researched?
Because we develop tools which enable us to look into glycans. So the first field of molecular biology which developed was genetics, because genes are a linear sequence. You read the sequence of nucleotides, you know the structure of a gene. And we are sequencing genes for 50 years now or something like that. And millions and hundreds of millions of people have been sequenced. And then later, technology developed to look into proteins. Proteins are more complicated because in addition to the sequence, they have a three-dimensional structure, they have post-translational modifications. And then people started to look more into proteins, into expression, into epigenetics. Glycans are several orders of magnitude more complicated than the proteome, because each, for example, immunoglobulins, they have one protein sequence, they can have hundreds of different glycoforms. So until a little bit more than a decade, there was no technology which enabled us to look into larger people cohorts. Actually, we did the first large study of the glycome. It was in 2008 when we studied the first 1,000 people. And until now, we did over 150,000 people. And as the technology developed, as we were able to look into glycans, then scientists were able to try to understand why glycans change, what glycan do, and so on. And now with the tools being available, and we know that they're important, people work on them more.
Okay. And before we get into GlycanAge, because I want to dive into that a little more, is I made this mistake when I first came across glycons. I thought it was the same thing as AGEs. I thought they were pretty, because they sound pretty similar to me.
Yeah, this is the very common mistake, and actually, many scientists do the same mistake because chemically they are somewhat related, so they have something to do with the carbohydrates. But biologically, they're completely different. So there is this process of molecular damage caused by increased glucose. So if there is high glucose in the blood, this glucose chemically reacts with the proteins. One of the most abundant protein is hemoglobin, and we normally measure this as this HbA1c or hemoglobin A1c, which is kind of a cumulative damage of too much glucose. So it's a chemical damage. Glycosylation is an enzymatic process with hundreds of genes, which creates thousands of different epitopes. So it's something really completely different. And it's very important that people do not associate GlycanAge with just increased glucose and diabetes and other problems which come with that.
And how fast can glycans shift in terms of positively? I don't know if that's the right word. Positively shift.
Yeah. So until a couple of months ago, I would say it takes weeks because immunoglobulins have a half-life of a couple of weeks. But then we did several studies of people with acute infection, including COVID, influenza, and also bacterial pneumonia. And then we learned that in a stage of acute inflammation, it can actually happen in a few days.
Oh, wow.
But I would say for example, if people get COVID, the GlycanAge can go up for 10 years in 2 weeks or something like that.
Oh, no.
And we are just now submitting a paper showing that actually people with more severe COVID change glycans faster than people who had only mild or asymptomatic COVID.
Okay.
So, but it's not only COVID, it's also influenza does the same thing. So it's not a special virus, it's the response of our body to a viral infection. But normally, if there is no acute infection, glycans change relatively slowly. So if people start to do some kind of intervention, if it's a lifestyle intervention like changing diet, starting new exercise program or so on, usually we see changes in 3 to 4 months. So it does take time to change. It's a very long-term measure, this GlycanAge. If it's hormonal intervention, for example, women taking hormone replacement therapy, the effects can be visible within a couple of weeks already. Because if you change lifestyle, it does take some time for the effects of the change lifestyle to be visible in any form. And then glycans react to these molecular changes. So if it's a lifestyle, it's a couple of months. If it's some kind of molecular hormones or some other pharmacotherapy, it can be a couple of weeks.
Okay. And I'm curious, I'll go back to the COVID thing real quick because it's top of mind since I'm a few days into my COVID experience. And what's some of the, I guess, some more discoveries that you found related with COVID and glycans?
So we haven't done much because, COVID is here for 2 years. We got serious COVID cohorts only in late 2020 because Croatia missed this first wave, and we just got some samples from Italy and Spain in the first wave. And what we learned is that the people who will get, who are at higher risk to get more severe COVID usually look older in their GlycanAge. And this is actually something what David Sinclair and I published in March 2020, where we said, okay, we know that age is the most important predictor for the severity of COVID, but it should not be chronological age. It should be biological age, because people of the same chronological age can be very different metabolically.
Absolutely.
And this proved to be right. So GlycanAge is a better predictor of the severity of COVID than just the chronological age. And so this is something we published last year. And what we are now about to publish is this change also, not only that it's a predisposition, but that the disease actually changes the glycom, or our response to the virus changes the glycom. And then the way how we change may be affecting the outcome of a disease.
Okay. And I was going through the GlycanAge website, and I saw that there's been studies published on glycons and life expectancy as well. And
so this is what I was mentioning earlier about the different population cohorts. So the best predictor of individual GlycanAge is actually life expectancy in the region where you live. So people who live in poor countries, and it's also highly correlated to the GDP or to Human Development Index. So people living in conditions which are kind of limiting their lifespan are moving faster in this GlycanAge than people living in better conditions. And also there are some diseases like the Down syndrome, which associates with accelerated aging. Also, their glycans will change much faster than glycans of the healthy people.
I hope the future of health gets this out more in mainstream, to where, like we were talking about before our call, is that a few days before I showed any symptoms, my heart rate started skyrocketing up. And I just think about, if we had things like that, and then we also knew like our biological age, like how much more we could help people with just simple things like that.
Yeah. So, I think one of the key problems we have with the medicine today is that medicine or the healthcare sector gets involved only when people get ill.
Mm-hmm.
So when something stops functioning, then you go to hospital and say, oh, I'm ill, I'm not good, help me. But the disease is a long process. We know, for example, that in many inflammatory diseases, glycans would change up to a decade before disease is diagnosed. So when you look at the molecular level, and when you look at these biomarkers, you can get a 10-year warning.
Wow.
That you are moving toward disease. And then you have these 10 years time to change your lifestyle and maybe postpone it for another 10 years, or maybe even completely prevent it. Because unfortunately, when there is something we call a disease, meaning you came to hospital because something does not work, you have pain in some of your organs, this is usually beyond the point of no return. And actually modern medicine likes it because they want to have a patient to treat. They don't want to cure people, because if you cure people, you lose the patient. So the way that the modern medicine functions is, they give you a label and then they treat you for the next couple of decades. And this preventive medicine, which is preventing diseases, this is something which is generally not reimbursed in any healthcare system, because it's just, that's the way for the healthcare system to lose money. So this is something what people have to do individually. We have to make our own decisions that we will kind of invest early to prevent or postpone diseases. And probably with future, this will become also the mainstream in the healthcare sector, because at the moment, the rising costs of the healthcare is bankrupting all the healthcare system, and And, I think US is close to 20% of GDP going into healthcare, which is unsustainable. You cannot go with 70% into healthcare. So something has to be changed.
Absolutely does. And wow, 10 years. I mean, I think of my dad, and, if he had a 10-year, like, it's basically like a check engine light on a car that comes on. 10 years.
So that's exactly the same, a similar analogy, which I often make, because sometimes people tell me, I don't want to know my GlycanAge because I'm afraid, maybe it is bad. I don't want to know it. But it's like, as I said, not checking your engine. Because if you just drive your car until it drops dead, that's not the best way to do it. You want to check it regularly, you want to change oil, you want to see if you're doing something wrong. And I think this is the same thing we should do for ourselves. We should be checking some things which can inform us about the future development. And fortunately, at the moment, there are not so many good prognostic markers. There are some good genetic prognostic markers. But the problem with the genetic marker is this is something you cannot change. So if you have a higher risk for heart attack, whatever you do, your genetic risk will still be the same. Mm-hmm. While in the same time, there is one single glycan within the IgG glycan, which was found to be more predictive of the future cardiovascular events, although in women. So not in men are a little bit different, but in women, the single glycan is more predictive of a future heart attack or stroke than the entire AHA score, which is the index by the American Heart Association, which calculates the risk of the heart attack in the future. And we have similar biomarkers for diabetes and for some inflammatory diseases. So not everything is the GlycanAge. GlycanAge is just one of the tests which can be done on glycans. And I think there is a great future in glycans as biomarkers to predict diseases, because glycans integrate genetic, epigenetic, and environmental information the same way as diseases. So disease integrates your genetic information, your epigenetics, and your lifestyle. So this is what makes glycans a very good predictive markers.
Mm-hmm. And so do you think, because I know we've mentioned it a couple of times, you think environment's the biggest affector of the glycans, affected them negatively?
So environment is very broad term. So when I say environment, this includes diet, meaning what you eat. It includes exercise, meaning how much you are physically active. It includes your sleeping pattern, and includes level of stress. And I think these are the four more important components. So sleeping, stress, activity, and diet. And more or less, we all know what is a healthy diet, that we need to exercise, that we need to sleep well, and that we should not be under stress. But it's kind of an impossible mission. No, you cannot live in the modern world and do everything in the way it should be done.
No.
So what GlycanAge can help us is to identify which of those four components are the most important for us. For example, initially when I wanted to improve my GlycanAge, I tried to sweat it out, meaning I was hiking in the mountains for 3-4 hours a day for 2 months. And of course, I did lose some weight. I was physically more fit, but my GlycanAge did not improve that much. And in alternative approach, I was just controlling my diet. And by just not eating too much, nothing special. I do have a couple of kilos extra. So just by losing this extra weight, my GlycanAge got improving. And then I also tried to sleep more. Didn't help. So for me, it was not sleep, it was not that much exercise, it was more diet, and probably also stress, but this is something which I cannot control in my lifestyle. There's too many things which I can't control. But at least I know, okay, I don't have to kill myself in the gym. Mm-hmm. If I go hiking twice a month and maybe, twice a week, and then maybe 1 or 2 more times in a gym for 45 minutes, that's fine for me physically. But I have to control my diet. And we had an interesting, how to call it? So it's maybe kind of, we made the wrong assumption, because initially we thought, okay, let's try to solve people's problem by exercise. We started collaborating with gyms. We started to collaborate with the local faculty of kinesiology. We had thousands of people exercising, checking their GlycanAge before and later. And majority of people got worse. Because if you, especially in middle-aged people, if you just force them to exercise, they usually exercise too much for them.
Oh, yes.
They get more pro-inflamed than, you have to have an optimal level of exercise and the relaxation, and also stretching and other things. So we are kind of now working with some of the personal trainers to find the optimal solution for everybody, and using the GlycanAge to see whether we are doing it well or not. Because if GlycanAge goes up, means you are overtraining. So slow down a little bit. And then if it's going down, you're doing something good.
I'm going to try this on my next time I train for a marathon and everything, because the training gets pretty intense, because I still keep my weightlifting regimen as well on top of all the extra running.
Yep.
And
so we had a cohort of ladies preparing for the bikini fitness, which is really vigorous. They lose all the body fat, and they all got older.
I can imagine.
And then after the competition, they got better again. But this period was actually not healthy for them. And sometimes we all think that it's ideal to be extremely fit to be able to do many physical things. But think about professional athletes. When they're in their 30s, we start to think they're old, because the wear and tear of the professional athletes is just making them old. So it's not the most optimal way to go through life. Of course, physical activity is extremely important, but it has to be balanced with relaxation.
Yes, I prepared for basically something like that, like a men's show. And I didn't do the men's show, it was more like a photo shoot. And I tell you, when you got to really low body fat, there was no GlycanAge back then, but I could feel like hormonally, I could feel like, oh man, I felt terrible. I looked great, but it felt much terrible.
Yep, I would agree.
And when I got when I got a little more fat back on me, I felt 100% better again. So it's very funny that people think that when they see you extremely ripped or shredded, that they think that, oh man, that's the pinnacle of health. It's not really the pinnacle of health, because you're only going to be able to keep that look really for a little bit, and then it's going to go away.
Yeah, and also we did some research, and there are some people who are better where they're not too skinny. A little bit of fat actually gives you some kind of a balance. So it's very individual. People are not the same, so it's very hard to have the universal recipe for everybody.
But I think this is just one of the key tools for that future of medicine and health in the future, where everything's N of one and it's personalized 100% to that person.
Yes, that's the future. We have to get there once.
And so what's on the horizon for you? What are you, I guess, interested working on and studying these days?
So we are the largest lab to look into glycan biomarkers in the world. So we try to collaborate with the leading researchers everywhere, and we virtually collaborate with Harvard, Hopkins, Yale, Stanford, Oxford, Cambridge. So people doing interesting studies, interesting intervention or interesting cross-sectional cohorts. Then we analyze glycans and add glycans to other omics data they do, because glycans are important, but glycans will not tell you everything. We have to get genetic information, we have to get epigenetic information, glycan information, microbiome, metabolome, and then by putting all this together, we'll get this unique signature of an individual, which can then be used for this precision medicine at the level of a given patient. It will take decades. It's not tomorrow, but this is somewhere where we are going. I have a very large research group. I have over 50 people in my team. We analyze 30, 40,000 people a year, and we try to understand what glycans do in life at the molecular level.
And so I have some of the listeners out there are leaders of their own team and everything, and you're leading 50 people. So what are 2 to 3 key leadership principles you would say in leading a team of 50?
Oh, it's extremely difficult because I'm leading a team of 50 extremely smart, creative scientists. So you cannot actually lead them. No, they don't allow somebody else to lead them. They all want to be their own leaders and creative minds. So the only thing I do, I try to coordinate and kind of mold them in one or the other direction. So I don't lead 50 people, and because the best people do not allow to be led. They can be guided a bit, they can be advised, but they cannot be micromanaged. So I have a very diffuse leadership ways. Actually, I go to my lab maybe twice a week, and I just create as good as possible conditions for them to work. Actually, in 2013, the scientists declared my lab as the best lab to work in the world for scientists in industry. So we kind of tend to have a good creative working environment.
Yeah, so you're definitely doing something right then.
Well, people are always complaining, but we are located in Croatia, which is not the most prestigious scientific country in the world. We are one of the poorest member of European Union, but we managed to create a lab which is the best in the world in this field. So it's we're a good team.
All right. One of my good friends went to Croatia, I believe 2 summers ago. He said it's an absolute beautiful country. He went all throughout Croatia.
Oh, it's a very beautiful country. Just people don't like to work very hard in this country. Mm-hmm. And this makes us a little bit underdeveloped. We enjoy life more than what we work.
When that reminds me, when I went to Portugal, and I was in Porto, and they didn't know I was American until I started talking a lot. And there's like, I knew you were American because you kept talking about work, and today's a Sunday. And that's not really what we do over here.
Yep, I would agree.
So that's a good thing. But this has been a very enjoyable conversation. And the last thing I guess I got to ask is, when people take their first test, how many times do you think they should get tested in a year?
I usually get tested every 2 months.
Okay.
But I own the lab and I don't have to pay the test. So this is not a cheap test. Test is something like $340 or something like that. So I would say, young people, and by young, I would say below 40 maybe, and who are not changing anything in their lives, once a year is more than enough. If you're good. So if you do a test and you're good, maybe repeat it in a year.
Okay.
If your GlycanAge is not good, and then you decide to try something, to change it, then I would say do it every 3 months to see whether this works or not. Because, for example, I decide to go on a diet. I hate going on a diet, I like to eat. And then if in 3 months I see that this is actually working, this is extra motivation for me to try harder. But for example, if I make a wrong decision, I just force myself to go in the gym, and then I see after 3 months it's getting worse, then I think, okay, I have to change something. And then when somebody is thinking about changing or doing interventions, then it could be frequent. Once things get better, it can be maybe once a year.
Okay.
For women, we know that the GlycanAge is very good predictor of perimenopause, because the perimenopause is a very difficult period because the majority of women don't get diagnosed on time, and then they get misdiagnosed. They got all the different crazy treatments for something which is just a transition from a regular cycle to the menopause. And the GlycanAge changes extremely quickly in the perimenopause. So the pace of changes increases 2 or 3 times. So if women start kind of tracking their pace of changes in their early 40s, so do it an annual test every year, and then once you see that it accelerates, then again, it's good to have it every few months to see whether it's really this hormonal problem, because GlycanAge is kind of HbA1c for estrogen, because HbA1c is a long-term measure of glucose overload. GlycanAge is a kind of a long-term measure of estrogen concentration. Estrogen is a very strong regulator of GlycanAge. So then in this period of perimenopause, it could be done a little bit more frequent.
Okay. Wow. That's interesting. That's very interesting. So I'm glad I remembered to ask that. And so the last thing here is, where can listeners keep up with you and all the adventures and find out more about GlycanAge?
So it's glycanage.com.
Mm-hmm.
That's the site which is selling GlycanAge. We have another lab, which is my research lab, but for this purpose, the glycanage.com is the best solution. And they have Instagram, and I think Instagram is the most used channel, also LinkedIn and Facebook and Twitter. But I think Instagram, they do most of the things in Instagram.
Okay. And I will have all of that in the show notes for the listeners out there. And once again, Gordan, thank you so much for joining me on here. This has been a very interesting conversation.
Thank you for inviting me. I enjoyed it.
And the listeners out there, stay awesome and continue to be limitless. Peace.